Hi, everybody. Welcome back. Let's start topic 5C. Now, 5C is really quick. We only spend a couple of days doing this. It's basically how to read some symbols on weather maps. 5D is going to take us into more of what those symbols mean, but I found that it's helpful to be able to recognize them first, so that's not a point of confusion when we get there. This might be the easiest thing we do all year if you use your reference tables. So, station models. When we gather weather data from literally hundreds of weather stations across the country, we have to find a way to put that information in a usable, easy to read format. Well, there's a lot of stations, and there's a lot of information we need when it comes to weather. So when we put them all onto a map at once, things can get really confusing really quickly. Now, luckily, there's all sorts of great websites like Windy behind me there that can take information and turn it into pretty colors and moving pictures, and that's super handy. And honestly, that's probably where all of it will be in the future. But being able to read these is also a handy dandy thing. So we'll take a few minutes and do that. Now, here's what it looks like when we start laying on some more of them. You can see the country sort of disappeared uh, behind the information. That's not all that helpful. I mean, if you zoom in, you can get the more specific information, but from a distance, that is not at all helpful. So we're going to look at one at a time. Thank you very much, or just a few at a time and try and interpret them. So this is on page 13 in your reference tables. And you don't have to memorize a lot to do this because there's a key. The key is right here. This is what we're going to learn how to read. It tells you what every single thing is on the locations around our diagram here. And they're always in the same spot. That's the critical component. They're always in the same location. They always use the same units. So everybody's speaking the same, albeit encoded, but they're speaking the same language. So this is what we're going to sort out here in the next couple minutes. So let's say we have a typical winter day at the airport, because that's normally where these readings are taken, is at airports or National Weather Service locations, someplace kind of official. I think the one in Watertown, there might be one at the water treatment plant. So it all starts off with a circle. That's innocent enough. The circle represents the sky, and how colored in represents the amount of cloud cover. So if that circle is open, like the one on the screen, no cloud cover, it's 100% clear. If the circle is colored in like that, you can probably guess that it means, right, it means 50% covered. And fractions might not be your favorite thing, but I think we can handle this. That's 3/4 cloudy, 75% cloudy. And if it's all colored in, that's telling me that it's completely overcast, 100% cloud cover. In the left-hand corner, the number there is always going to represent the temperature, and it's always going to be in Fahrenheit. This is one of those things that the National Weather Service has not forced us to convert to Celsius yet. So the numbers are going to be given in Fahrenheit. Is there going to be a little F there to tell you that? No. We don't put any extra symbols on these because they already get crowded. So adding decimals when we don't need them, when we can kind of assume they're there, adding labels, we're not going to do it. The lower left-hand corner is the dew point temperature. As we discussed in the last topic, the dew point temperature is the temperature the air is saturated at. It's always lower than or possibly equal to the actual temperature. Again, it's in Fahrenheit, but we're not going to put that down. We just know that it's there. Next, wind. Wind direction is going to be indicated by a line coming off from the circle. And it's pretty straightforward. Think of it like an arrow sticking out of a target, kind of. So this one comes from the north, from the top. So that's north. That would be an east wind. And you can sort of yell it out with me here. That's going to be, whenever you try to eat, or whatever terms you use, that's going to be southeast. and northwest. So no tricks, just the line represents the direction it's coming from and how it's named. Now, wind, we don't just want the direction, we need the velocity of the wind. So we need direction and the speed. To indicate the speed, they add an extra, they call them feathers onto the line, feathers, flags, whatever you want to call it. If there is a line out at the end of our wind direction indicator, that line is going to represent 10 knots. Now, if there are, now a knot, you say, what the heck's a knot? A knot is essentially a mile an hour. They're not they're not exactly the same. If you remember back when we were talking about dead reckoning with navigation, they used to literally throw something overboard and count the number of knots coming off the ship in a rope to figure out how fast they were going. That's where this term comes from. But a knot is 1.15 miles an hour. For most purposes, they're roughly equal. If the flag is in a little bit from the end, and it's going to be shorter, that's going to represent 5 knots. Now you can combine them as well. So if you had two big flags, 10 plus 10 is 20. If you had a big flag and a little flag, 10 plus 5 is 15. If you have that, you would have, what would you have? 10, 20, 35. 35 knots. And it goes from there. Now, if it's a really strong wind, we're talking tropical storm, hurricane, something like that. Honestly, we don't need to know for everyday applications necessarily how strong it is. If it's over 50, we're probably just going to put on there that little triangle, and the triangle represents gale force winds, so 50 plus miles an hour. If you had a hurricane with 150 mile an hour winds, you wouldn't want to put 15 flags down the line. It would fill it up and be cluttered and hard to count. So if it's really windy, they might just use the gale one. All right, so in this case, we would have a wind from the southwest. And if it was that strong, that represents 10, 20, 5, so 25 knots. So a southwest wind at 25 knots. In between those two, there's a couple of things that can actually go in between those two. If there is a symbol, like the asterisk that just popped up there, that represents what the present weather is doing. As I look out my window right now recording this, it's snowing outside, and it was snowing at this weather station as well, apparently. That little symbol represents snow. So this is also on your reference tables. Snow is a little asterisk. If there's a dot, it's rain. If it's sleet, it's a triangle with a dot. If it's freezing rain, it's that. You can see it. Some of them are a little goofy, but they're distinctive, and that helps. Yeah, I don't think there's any trick to it. You won't be asked anything other than these. Yes, there are many other symbols that could be used if this was your occupation, but these are the only ones they'll ever ask you on a state test. So here it's snowing. The other thing they can put over there, and I don't remember if it pops up in the slideshow or not, if there's numbers over here, you might see like a 5. That would indicate the miles of visibility. It could be 1/2, indicate half a mile of visibility. If there's no limit to it, they don't bother writing it on there. They just leave it blank. It's like if there was no interesting weather right now, that could be blank. There might not be any value in it. Lower right-hand corner is going to be the precipitation in the past 6 hours. This is the only place where a decimal point is used. These are really small. They used to fax them out. I don't know if you guys know what a fax machine is. They're kind of antiques at this point, but the resolution's not the greatest. Pretty low def. And so they didn't put too many dots on there if they could avoid it, because it was hard to tell if it was a speck on the screen or the paper or fly pooped on it or whatever. But in this case, they do use a decimal point, because precipitation can vary greatly in 6 hours. It could be fractions or hundredths of an inch, or you could have several inches, so they have to put it in there. So that is 0.17 inches of precipitation in the previous 6 hours. There's our visibility. I knew it would pop up somewhere. But in this case, there's 3/4 of a mile of visibility. If it's more than 10 miles, they won't bother. Now, if you're going to mess something up, it's usually this one and the next one. So if you're starting to get bored at this point, pinch yourself, slap yourself, get a drink of water, whatever. Pay close attention here because this is what you'll mess up. So this is the pressure in millibars, but it's not the pressure in millibars. It's the abbreviated, encoded version of it. So the pressure is not literally 964 millibars. That 964 stands for something else, which we'll get to in a second here. And this one is what the pressure has been doing for the past 3 hours. It's a pressure trend. So since there's a minus sign here, it says the pressure has gone down in the last 3 hours. And it hasn't gone down 12 millibars. It's actually gone down 1.2. They leave out the decimal here. You have to put it back in. They also leave out a decimal up here and some stuff too. So we have to figure this out. Now that 964, back to that. That was the encoded, the code version of the pressure. The actual pressure was not 964. Now, normal atmospheric pressure on Earth ranges from about 960 to 1040. It can be a little lower, it can be a little higher, but that's the normal everyday range you wouldn't be shocked to find. The last digit, when this is encoded on a station model, the last digit is always in the tenths place. So you're going to put a decimal point, in this case, between the 6 and the 4. Now, that would leave you at 96.4. That is not a normal air pressure on the planet. So we have to add something to it. Now, if we put a 10 on the front of it, because we're always going to add either a 9 or a 10, if we put a 10 on the front, that would mean 1096.4. That'd be too big. I mean, it's not impossible on Earth, but it's really improbable. So that's higher than 1040, probably too high for any normal situation. So if you try a 9 on the front, 996, that's totally not abnormal weather at all. That'd be the way to go. Now, the simple rule, it's sort of like rounding. If you ever did the rounding in probably elementary school, 5 or above, give it a shove, that kind of thing. So if the converted number is more than 500, like we had 964 on the previous page, if the converted number is more than 500, you're going to put a 9 on the front and a decimal point between the last two numbers. So if it was 887, definitely more than 500, you're going to put a 9 on the front, decimal point between the last two to give you 988.7. If the converted number is less than 500, you're going to put a 10 on the front. It needs a little more help. It's a smaller number, so give it the bigger help, and the decimal point between the last two digits. So it might be 132 you saw on the station model. Well, less than 500, so you're going to put a 10 on the front, decimal point between the last two digits. Let's practice a little bit. I'll go kind of slow, I guess. So do these in your head, think it really loud, maybe it'll work. So we have a 184. It's less than 500. So from what we previously said, less than 500 needs more help. So we're going to put a 10 on the front, decimal point between the last two digits. So it'd be a 1018.4. Now 748 is more than 500 for sure. So doesn't need as much help. More than 500, you put a 9 on the front, decimal point between the last two digits. So we get 974.8. Next, 951. Definitely more than 500. 9 on the front, decimal between the last two digits. All right, gonna pause for just a second here. Take a look at the next few, see if you can get them in your head. All right, so hopefully you got at least a couple of those. D, 1025.9, E, 988.3, and F, 003 here, less than 500, so you get a 10 on the front, decimal point between the last two digits. Now, the pressure trend, it said the trend was minus 12 with a downward slant there. So what this tells us, and this is really important because if the pressure is rising, usually that means better weather is coming. If the pressure is falling, maybe a storm is coming. So this is important. It also tells us about what the wind's going to do. So it means it's gone down in the last 3 hours. So 3 hours ago, it was higher than it is now. It's gone down, and what this stands for is 1.2 millibars. And the line on the end is not always there, but in this case, it starts high, it goes low. So that tells you it's steadily decreasing. So the last digit's the tenths place. The pressure has decreased 1.2 millibars during the previous 3 hours. And like I said, the downhill line represents a steady decrease. It could have been like down and flat. It could have been flat and then down. Honestly, that line is not always there on the ones we do. So don't get in a twist if you don't have a line to put there. It's okay. If you don't have any information, don't worry about it. So it's gone down 1.2 millibars compared to 3 hours ago. Now, the question I will ask of you on the worksheets for a section of it is, all right, so we can convert, we can see the trend. What was the pressure 3 hours ago? So if you want to know what the pressure was 3 hours previous, what you do is whatever the sign was, we had a minus up there, you're going to do the opposite sign and put the number back onto the pressure that's there. So it's now 996.4, but it had gone down 1.2 millibars in the past 3 hours. So if I want to know what it was 3 hours prior, I'm going to have to put the 1.2 millibars back onto it, so add them, and I'd have 997.6. Had it been a positive trend, you would subtract the number from what it was presently to get the 3 hours ago pressure. So whatever the sign is, do the opposite mathematically once you convert it, and that'll tell you what the pressure 3 hours ago was. Again, not every sheet is going to ask you, hey, what was the pressure 3 hours ago? But sometimes I will. That's how you do it. So for instance, this is going to be the last part of the worksheet, so make sure we can do it. I have a 975, no, I have a 752, there we go. And I have a trend of plus 26 upward sloping line. So 75 point, or I'm trying to convert it in my head here. 752 is more than 500. So I'm going to put a 9 on the front, decimal between the last two digits. So it's 975.2. It's gone up 2.6 millibars in the past 3 hours. So if I want to know what it was 3 hours ago, I'm going to do the opposite. I'm going to subtract 2.6 millibars from my current pressure. You can use a calculator for sure, because decimals and lots of numbers flying around, I get it. So 975.2 minus 2.6 would give us 972.6 millibars. That's the way these work. Obviously, as a teacher, I love these questions because it makes you convert several things. It makes you do a little bit of math and a little bit of thinking. So don't be surprised if I ask you these. Next one, less than 500. So it's going to get a 10 on the front, decimal between the digits. So it's 1021.3 currently. It's gone down 1.4 millibars in the past 3 hours. So I'm going to add it back on to figure out what the pressure was 3 hours ago. So 1021.3 plus 1.4 gives me 1022.7. So I think you get it. If you want, pause it now, do these next couple so you can check your answers to see that you do actually get it. That's sort of important before you get to the worksheet. All right, so this one would be 999.1 after, or 3 hours ago. And this one, when you do the conversion, even because it's a leading zero, it's just 0.9 it changed. But you're going to add the 0.9 back on to get 985.5. So the first worksheet you're going to have to do is just doing some conversions. Remember, this whole thing is always there in your reference tables on page 13, so you can do anything I ask of you, honestly. This is your reference guide. If it says, in yours, it might say 75. The temperature is 75, but that number in the left-hand corner is always going to represent the same value, same thing. All right, So I think, yep, I'm going to have you do 5C1 now, and then we will go over it, check it, give you the answers, whatever it might be, for homework. So have a good one.